Welcome to this explainer. Today, we're stepping past the yellow tape and putting on our detective hats. We are acting as elite forensic investigators, and our sole mission is to crack the code on exactly how to secure maximum marks in the Cambridge Mathematics 9709 syllabus. Specifically, we're tearing into Section 2.3, which covers your sec, cosec, and cot functions. We're going to treat your upcoming AS or A-level exam exactly like an intricate crime scene that is just absolutely loaded with hidden forensic clues. I'll be your lead detective today, guiding you through the primary evidence so you can walk into that exam room completely bulletproof. Let's get to work.
Here's the dossier for today's investigation. We'll open the trigonometry case file, map out the core architectural principles, and establish our procedural framework. After that, we'll analyze the top 3 examiner warnings, deploy the method mark strategy, and finally, we'll lock the whole thing down with our case closed exam checklist.
All right, Section 1, the trigonometry case file, investigating Section 2.3. Let's get right into it. So you have to ask yourself, what actually separates a standard average grade like a B from that top-tier elite A-star success? Well, according to the senior examiners and the official Cambridge reports we've cross-referenced, it almost entirely comes down to how well you understand the complex underlying relationships of reciprocal trigonometric functions. We're not just talking about memorizing formulas here. Mastering the precise behavioral anomalies of secant, cosecant, and cotangent graphs and equations, that is exactly where the standard suspects completely fall behind and the elite candidates pull ahead. It's the ultimate proving ground. Moving to Section 2. Core architectural principles, the laws of the case. Let's look at the rules of engagement. Every successful forensic investigation is built on established laws. In our context, these laws are the assessment objectives built into the Cambridge exam architecture. Listen up because this is crucial. Cambridge isn't just testing your baseline memory of standard reciprocal identities. That's rookie stuff. Their assessment objectives target distinct cognitive domains. They want to see your baseline knowledge, sure, but they heavily grade your ability to apply those established principles and execute deep, evidence-based reasoning. They are cross-examining your critical analysis skills just as much as your calculation skills. You have to prove your case. And here is a massive piece of intelligence gathered directly from the principal examiner reports. Candidates who reference cross-topic connections achieve significantly higher marks. It's a huge multiplier. If you can integrate your sec, cosec, and cot trigonometry answers with entirely different areas of the syllabus, like, say, recognizing when a cosecant function acts as a strict boundary condition in a complex calculus volume problem, you are signaling to the examiner that you truly understand the entire mathematical ecosystem. You aren't just looking at an isolated fingerprint, you're seeing the whole scene. Which brings us to Section 3, the procedural framework, standard operating procedure. Let's lay out the exact steps you need to take. To build a truly unassailable answer, you've got to strictly follow this 5-step standard operating procedure. Step 1, identify the key elements in the text. Spot that hidden cotangent identity lurking in the data. Step 2, apply the relevant analytical principles to set up your framework. Step 3, and this is non-negotiable, execute your analysis with absolute clarity in your mathematical notation. Step 4, verify your results against the initial constraints. Check for extraneous solutions in your trig domains because they will absolutely try to trap you there. And finally, Step 5, present your answer using the exact terminology and format requested, matching the precise radian or degree specification. Skip a step, and you compromise the whole investigation. Section 4, Top 3 Examiner Warnings, Forensic Points of Failure. This is where we look at the historical mistakes. Case file freeze. Before we reveal this top-band analytical structure to help you clear your upcoming Cambridge sessions, make sure your intelligence feed is entirely secure. Take a second right now to subscribe to Ace the Exams, that's at Ace the Exams, and turn on all notifications so you never miss our weekly forensic exam updates. Whether you're cracking cases at IGCSE, O-levels, or AS and A-levels, we've got your back. Okay, let's look at the historical pitfalls. The intel here is clear. First, answers are constantly too vague. Examiners want hard, specific details. Second, candidates forget to check their final format and presentation, dropping the easiest marks on the paper. Third, answers are frequently completely detached from the specific context of the question. If your trig solution doesn't anchor directly back to the parameters of the case, it's a fingerprint match error. It instantly throws out your marks. I need you to see the massive difference in mark potential here. Misinterpreting an examiner's command words is fatal. A shallow, descriptive statement that lacks context will basically get you baseline tracking marks, at best. It's just reciting a textbook. But an evaluative argument anchored in the specific evidence of the question, like explicitly justifying exactly why you chose to expand a secant squared term over a tangent term based on the given domain, that secures the high-tier marking bands. You can't just describe what a function is. You have to interpret the relationships and draw airtight, evidence-based conclusions.
This quote straight from the files tells you everything you need to know. Top-scoring candidates demonstrate evaluative thinking. You have to step up and evaluate the quality of the mathematical evidence, question the assumptions built into the problem, identify the limitations, and above all, justify every single tactical decision you make with hard, written evidence. You are building a logic string. If you don't justify your choices, the examiner literally cannot give you the top grade. Section 5. The method mark strategy, the ultimate safety net. Let's talk about what happens when things go wrong. Because, let's be real, even the best detectives sometimes hit a dead end mid-investigation. What happens if your final calculation is just completely wrong? What if you drop a negative sign in minute 3 of a problem, and by minute 15 your final trigonometric identity is so far off base it's laughable? Does the examiner throw your whole case out of court? Do you just lose everything? Absolutely not. Listen to this massive examiner alert straight from the primary sources. Method marks can save you. The Cambridge grading system has a built-in safety net, and you absolutely must exploit it. The examiners are practically begging you to show you're working out. Even if your final calculation is completely dead on arrival, securing method marks for demonstrating the correct systematic procedure can totally salvage your grade. If you successfully isolate a cosecant variable using the right logic but make a basic arithmetic error later on, you still get rewarded for the process. But only if you leave a visible paper trail of your logic. Document everything. Finally, Section 6, Case Closed, Exam Checklist. Let's lock in our final suspect profile. I want you to keep this procedural audit checklist firmly pinned to your mental bulletin board for exam day. Rule 1, rigorously document all analytical working to secure those critical method marks. Rule 2, anchor all your math directly to the specific context of the question. Absolutely no vague textbook regurgitation. Rule 3, always verify your final presentation formats, ensuring your units, domains, and degrees are totally flawless. And Rule 4, build those cross-topic syllabus connections wherever possible to elevate your analysis to the A-star level.
The evidence is all laid out on the board in front of you now. You've got the theoretical framework, the procedural matrix, and the official examiner warnings right from the source. So the choice is yours. Will you treat your next 9709 past paper as just a random string of messy calculations, or will you approach it as a rigorous, elite forensic investigation? You have the tools to build a bulletproof mathematical case. Before you go out there and crack your next paper, make sure you hit that subscribe button for Ace the Exams. That's at Ace the Exams. Click the notification bell so you're locked in for all our weekly grade masterclasses, and drop a comment below sharing exactly which Cambridge subject and level, whether it's IGCSE, O, AS, or A-level, you're preparing to conquer next. Case closed. I'll see you in the next explainer.